Welcome to another video for physical science. In this video we're going to highlight sunspots, prominences, and solar flares. I've already made a video detailing what causes sunspots, so you can go to that for sunspots. But just to give an overview, these are irregularities in the sun's gravitational pull, and what they do, or the gravitational magnetic field lines that are created by the sun. And what they do is that they arrest movement and convectional currents that happen underneath the sun's surface. And they create these nice little cool spots in the sun's gas. So these gases are incredibly hot, but these particular areas just cool off just a bit. And if you recall back on the video that I made for sunspots, it looks dark for us, but those dark areas are actually pretty brilliant themselves. They're very bright. They just look dark to us because we're contrasting them with the extremely brilliant photosphere of the sun. So Galileo observed these sunspots, and he noticed that these sunspots rotated and they moved. And so because of this, he determined that the sun itself rotates. These sunspots also, they look small, but again, you got to recall that the sun is pretty large itself. They're actually bigger than the Earth itself. So as you can see here, we have some thermal imaging of these sunspots, and they're basically massive caverns of cooled gas on the sun's photosphere. So given that the magnetic field's irregularities in the sun are what cause the sunspots to be created, this is the exact location of where our next feature is created as well, the prominences. These prominences are massive loops of gas that erupt from the sun. These loops will extend from the photosphere all the way to the chromosphere, and they actually give a visual of the magnetic field lines. As you can see here in our images, you can see these magnetic field lines that are created, these balls, these strings of energy, these loops of energy that are made because of those irregularities. In fact, here you'll get an image of a very large prominence. These prominences are huge, as I mentioned before. Some of these are as big, or it can be as big enough to fit in the entire planet of Jupiter. So that kind of gives you an indication as to how large these are. Pretty impressive when you take a look. So our next feature is solar flares. These are dramatic eruptions near the sunspots, as you can see here. Now these solar flares can shoot out all the way up into the chromosphere, and they heat up the corona up to about 20 million kelvins. They cause magnetic storms in the Earth because they shoot out more radiation towards the sun or towards the Earth, causing interference in our electrical components such as our phones, our satellites, our telecommunication systems. So it's kind of like a lightning bolt hitting around your house, where it gives you an extra surcharge of energy, and it can fry our delicate systems. So you can see here some more solar flares shooting out from the sun. Now what you're going to see next is a CGI of the granules that we spoke of in a previous video. These granules are created by the convection currents, the movement of energy, the transfer of energy underneath the sun's surface on the photosphere. So this is the actual photosphere. Now of course, again, this is CGI. There's no way we could ever get anything close to the sun's surface, but that wave action that you see is created by the convection currents underneath. And you can see the prominences on the surface and some solar flares as well. So keep in mind, as you study the sun and you look at the sun's features, this is a very dynamic star. So there's a lot of movement, there's a lot going on, there's transfer of energy, there's fusion, energy creation that's happening at the sun, on the sun. Planet Earth gets to benefit from, we get to benefit from it. Okay, well that does it for our three features of the sun: our prominences, our sunspots, and solar flares. So good luck in your studying.